Hello and welcome back to the lab. Today on the bench, we do not have a repair project, but I do have a Q&A kind of sort of session. I have been getting a lot of questions about the AA501 relay boards that I made, which also go into the... I haven't test fit a non-A version of 501, but the section is the same. And I've had a lot of people express interest in the boards, and I've tried describing on how to use the boards a few times in email, and it hasn't gone nearly as well as I would have liked. I'm not sure if I came across and made sense or if I did not make sense at all. So this is a video that's going to kind of show the relay boards themselves, what you get if you order a set of relay boards from me, and what you will also need to purchase to populate the relay boards, because I do not sell them populated. If anybody would like them populated, that is something I can do. It doesn't take long. I'll have to charge a little bit of labor for it and parts, as unfortunately these reed relays that I ended up using, they're good high quality reed relays, but they're not cheap. But here is a set of the relay boards. Actually, this is two sets. I'll get a different piece, but when you order a set of relay boards, I do not have any broken apart, so we'll snap these apart. So this is a set of relay boards. You have a set of 4 and then 1 extra. So you need 1 and then the 4. This makes a full set. Now when I send them out, I will take off, I don't know if you guys can see this board material here. These are actually nice and sharp and love to stab me when I'm working on these, but I'll file these off and sand these off so they'll be ready to go in. Believe it or not, the tolerances in the unit are so tight that if I leave that little board tailing on from the fab, they won't fit. Not enough room. So here's the boards that I made up. They're relatively simple boards, not much to them. But the one board holds 4 relays, the other board holds 1. That was due to mechanical design in the 501. There's a CADC, I believe it's a CADC relay, resistor that sits in between the two sections. So there's a group of 4 and then 1 relay off to the side after some components. I designed these to take 0.1 inch headers. This is a strip of 2.57 millimeter, but these are designed to be broken apart. And if you look, they will pop in to the board just like that. So you can actually do an entire strip of 0.1 inch headers and then on the back side, but then you'll need sets of 2 for the front. That's for the pinouts of the relays. The original relay is a 4-pin and a 2-pin. The reed pins go here to the middle side, and then the 2 outer pins are what drive the relay coil to close the relay. So 0.1 inch headers, you can size these. The middle, let's see, where's a pair of pliers, because I always stab my fingers when I'm doing this. If you squeeze the tip, you can actually resize where the plastic is sitting. Come on, focus camera. Where the plastic is sitting on the pin, so you can set them at any height you want. I did this specifically so you can, for quick assembly, where you can put an entire row in of pin headers and do those, but then you have to break apart for the bottom and use sets of 2, which isn't that big a deal. But the pin headers are really cheap. This is the same pin pitch that the Arduino uses, and it also happens to be the same pin pitch that the board in the AA501 uses, so everything lines up really nicely. As far as I remember right, the mechanical lining up of the pins was very well. You will also, on the one oddball relay, you'll need a set of 4 and then a set of 2, and then it's ready to go. So that's the boards. The relays that these were, and the pin headers. I was going to shoot this video yesterday, but my lab was devoid of pin headers. You can also buy Cost-wise, this was about $5 for all these pin headers, so not horrible cost-wise. To give you an idea of scale, here's a set of boards, and that's an American penny. The camera makes this stuff look a lot bigger, so we have the single board penny and then the 4 boards, or the 4 on its own. So when you get them, they're not huge, and there's also not a lot of room in the 501s for these relays. So that went into some of the mechanical design, went into picking of the parts. Speaking of the parts, here is the data sheet. As I noted on here, these are set for a coto 2332. It's printed on the silk screen of the board. And it's also a 2332-05-010. So if we look at the part number, it's a 2332, 2 contacts in form 1. The 5 is the coil voltage, which is 5 volts. And then the 01 specifies electrostatic shielding in the relay. We've got a coil going and we've got contacts going, so I wanted to use the shielded component for this particular application. I don't know if the shielding was necessary, but the AA501 is a very sensitive piece of equipment for distortion analysis, so I wanted to give it the best shot it could. The contacts of the original part were actually shielded by the coil of wire itself. So the coil was, if the reed contacts were this way in the relay, the coil was wrapped around the reeds this way. So I'm not sure if that's the same in the coto design, but it did work okay and calibrate. So the form 1 is this way. So it's a double pole single throw relay with the coil on the outer 2 pins. So pin 3 and pin 2 are the coil pins, and then it just passes the reed actually passes through itself. Looking at this schematic, form 3 would also work if there's a part shortage. It's just going to be a little bit more expensive part, and it's got a 3rd reed relay in it. So I have the board set up to where pins 7 and 6 are no connection, so it won't use those at all. So if lead times are causing problems, the 2333 may be a substitute part number that would work. There would be no connection into the 501, but I have not tested that. So that was just looking at the schematic off the top, so use that at your own risk. But I used a 332 in form 1. Let's take a look at the board layout, and let me get the parts layout, and I'll show you where the relays are. Okay, here's a printout of the A14 assembly, and this is the board that has the switching relays on it. Okay, these are driven by an inverter. It's U1060, which is a 1416, so it's a six channel, or it's a hex inverter, and that's what actually fires the relay contacts. The relays themselves are in this section right here. So the printout's not that great, but we can see the 4 pins leaving. We can see the 2 pins on the other side. That's the pin out of the relays. And the way this sits in the unit is we have the 4 board here. This is that space for these components, and then this relay gets the single board there. So that's how it lays out on the board. Now there's a height problem, and it doesn't need to be mashed all the way down to the board because there's some traces and things that run under these relays. But so you'll want to, what I ended up doing was soldering the pins here and then moving the plastic down close to the bottom to give me a standoff, and then soldering the pins on the actual board for the interconnects. So that gave me a spacing that I otherwise didn't have. So the relay board sits up off the main board just a little bit, but then I had a height problem because A14 is in the middle of the unit, and the relays can't be too tall or they bump into the board on the other side. So hence why I needed to pick the two 332s. There was a lot of mechanical decisions that went into that as opposed to any other reason for that specific relay. I have been checking because there's been a lot of interest in these boards for parts. The two 332s are out of stock at the moment, but I think Mauser said they expected about 340 of them to be in early June, but there is some lead time on this particular component. So if anybody is interested in the boards, let me know. I do not have any of the relays in stock, but if there is enough interest in, I do have boards in stock, but if there's enough interest in me selling populated boards, I'd have to work up a cost for that to move forward, and then we could probably facilitate that. At the moment, I am selling just the unpopulated boards. They don't even come with the pin headers. So if there's enough interest, that is changeable. But at the moment, there's been some passing interest in the boards, but there hasn't been a huge demand for them. Some of the symptoms that cause this problem, if you have stumbled on this video and didn't catch the other two alignment videos of the AA501s, if you're having range switch problems, that's what these relays do in circuit. Is these help the unit with ranging, especially in the auto range. If these relays aren't clicking correctly, then the ranging will be all screwed up and all over the map. I've seen this manifest as galloping auto range, where it's just hunting and will not settle down. I've seen it manifest as the ranging doesn't work at all. It's just stuck on a range and can't switch. Really depends. These particular relays are very integral into the ranging system, so into the range selector system. So that's kind of the behavior. So if any of yours are exhibiting range switching problems, I would start here, if not some of the driver ICs that drive these. Although for me, the two that I have in the lab, we have one that has not needed relays yet, but it probably will, and then one that does need relays. That needed relays. The AA501 needed relays. The AA500 or 501, or no, I'm sorry, the AA501A needed the relays. The AA501 needed some other ICs replaced, but the relays were fine so far. It's just a mechanical part, wear out over time. It happens. Not a huge deal. And this is there is a solution if it's needed. So with that, I will leave links to the other videos. If you're just stumbling on this one first, I will leave links to the repair videos in the description below. And I will see everybody in the comment section. And in the next video, more is always on the way.